stop 14 will be similar on 14 pin devices also. Right? So on launchpad also, when you are putting 14 pin devices, bottom 6 pins goes unused, and you can still fit in the VCC, test, reset, ground, your 1.0, 1.6, 1.2, everything matches correctly. So you can see that 7 till 7, and from this you have multiple pin muxing done, but here it is very small because we are adding one port and one timer when we go from 14 pin to 20 pin device, right? So this will be another handy thing throughout the labs. Right. I'll start with my first thing, what happens at reset, right? So at power up, so there are 3 kind of resets, POR, BOR and a PUC that is defined in a user guide as well. All these 3 from user's perspective results into starting at void main void or int main void. So what it results into it, starting your first instruction of the code. So at power up, a brown up circuitry holds device into reset under till VCC point is above hysteresis, which is BOR present. Reset and NMI is configured as a reset, so it acts as it gives valid reset. All the IOs are configured as default inputs, right? So all the pins are actually into high impedance state, buffered state, tri-stated, right? Clocks are configured. Now what these clocks are configured and how these are configured, I'll explain. Peripheral modules and registers are initialized. Where to see those initializations is from user guide. I'll again point it. I am also going to use this document every time where you can see it. Right? So these are the default values. Whether you can read or write to that particular bit is there, I mean reading and writing facility is there or not, and what is its default value. So each SFR will have its default value, which is 0 right now in this particular case, which will be at reset. That is what going to happen, right? Status register, there is something called a status register, program counter. We are going to see it in detail. Now, watchdog timer, we have watchdog timer which operates into 2 different modes, okay? So the 2 modes are, a watchdog timer can act as an interval timer, which is, give you an interrupt at specific time duration, and it can also act as a watchdog, normal watchdog. What is watchdog's functionality? When system goes out of control, you have to reset your device. So watchdog timer serves both the purposes. It can either reset your system when it is out of control of the software, and other thing is it can act as an additional timer where we can term it as a interval timer mode. So at start, by default, the watchdog timer is always a watchdog mode. So if you don't stop it at start, you don't take care of that software control, what happens is device starts resetting. So any code you write, you are developing, first statement is going to be you hold that watchdog timer, you stop that watchdog timer, right? Because at reset, watchdog is initialized as watchdog, and then later on in your system you can define when to start watchdog, when to stop watchdog, whether really you want to use it as interval timer or a watchdog mode, whatever you want to do it with this. Program counter is loaded with the address contained at the reset vector location. Reset vector location is always fixed. Where it is going to point, that parameter is going to get changed with the device, right? With different devices, where it is going to point, sorry, this is, if it is FFFF, the device will be disabled for minimum power consumption, and the start of your code will always be pointed at the reset vector, right? So that was hardware, right? That was hardware. what MSP 430 as a chip does at start or at reset, that was hardware aspect. So what we need to do, software, initialize stack pointer, top of the RAM, that is already defined by the project settings, right? Reconfigure clocks if we want to configure them. Initialize the watchdog timer for the requirements of the application, usually off for debugging. Since we are going to debug our sessions, I already mentioned that we at start, better we stop it and then enable the way we want it, right? And configure peripheral modules. Now, what peripherals we have is, timers and UARTs, ADCs, those, right? First thing, everyone opened this, right? Everyone saw LED blinking? Sometimes there could be some problem with some cable, or last year I faced one issue where the cable was shorting this, so this was never coming up. We have to replace. So just have a look at it, that everything is in place. When you put this on, LED should start blinking. This programmer also creates a virtual COM port on our systems. That is, MSP 430 application UART will be seen in your device manager. This will create a virtual COM port, which can also be used for UART debugging if you want to do any, like a small GUIs or something like that people may prefer to do, that can be done. And the drivers for those will be installed via CCS and IR. Anybody has any problem in Launchpad? Please, with me, you also please open the data sheet and the user guide of the device, which at whatever point I have mentioned. Right, it is available in your pen drives. Right? Please start CCS. If you have another instance of installation of CCS, please make sure that you are starting one which you have installed right now. It will be available, that icon will be available in installation folder, right? For me, I have two different CCS versions, but this shortcut takes me to 5.5, whichever is the latest has been given to you. So, sorry. So this is going to bring me to selecting a workspace location. Now they may go to by default location. What I want to do is, I am creating for these labs, I am creating a folder on desktop which I will be pointing to MCU Deep Dive Pune, right? And I am going to give this particular path. Everybody is with me here? So browse, I am going to give first path. Pune Labs. So you have to give paths. Whatever are the related files, relevant files, it is going to create in that path, right? So this is how it is going to look alike. I'll also show you where to find out what contains here. It is going to take me at Resource Explorer. Everybody is on the same page? How many are not? Okay. Right. So with Explorer, what we get here? Just look at, I'm just going to spend some few minutes on to explain what is available on this. So whatever installation things you ticked, right, for C2000, for MSP430, for Stellaris, it is going to install components of it. So there is a MSP430ware, right, which will always be present here. If you can create a new project from here as well. Examples can be seen. Now I am going to take you to MSP430ware. So what is MSP430ware? What it is there is devices, development tools, libraries, right? So there are few driver libraries and all we are going to discuss in session, next session as well on this. So I am talking about G2XX. You can have a user guide here, data sheets, errata sheets and code example. Everything can be available here. Then you have code examples. I am talking about, I said there are two more families, G2XX4 and 2XX5 as well, which also is present. Alternatively, you can click on the right side of the plane and you can just go to that particular device, right? So G2X. So 2X53 is our device. Sorry, I wanted to use code examples. 2553, right. So these are all the code examples which I showed you earlier, right. Whatever code examples I showed you, those are kept here. When you click on particular code example, it creates a project for that code examples and you can immediately test it, right. So labs you can also test whatever is available here. Those are additional labs to what we are conducting, right. So we are conducting very basic labs to make you understand MSP430 architecture and the hardware, right. So this is one thing, what information you can expect here. Now when I close it and if you again want to look at it, you can just go to View and TI Resource Explorer, will take you again to the same place. Now how do we create a new project? You can go to File, New CCS project, right. I am going to give name as lab 1, select a family MSP430 and then a filter will take you to G2XX and then G2553. There can be an empty project. Now there will be multiple people, some would like to write the code, some would like to test the code. So they can either say empty project or empty project with main.c and start writing code, or they can import a code file named as lab1, which instruction is given here, that create a new project named as lab1 and if required refer to the code file lab1.c. So if I have created an empty project, I can also create a new source file which is available here. Now it is created 14 November, ID is coming, A0, sorry, hash include G2553.h. Right? This is going to be my structure of the program, right? Initial thing. So I have a loops defined. What was the first statement which I explained? Stop the watchdog timer. So to make it stop, first statement of my program, which always going to be wdtctl, this is a password for the watchdog, and right, this statement is going to stop the watchdog timer, right? Now I will go to the so I have a LED on pin 1.0, right? I am going to have a look at port 1.0 schematic, right? It is on the page number 43. So to drive an LED from a IO pin, I need to define it as an output, right? Everybody created a project, by the way? I didn't go slow actually, I realized right now that I created with my pace, but everyone created project? Any issues with creating projects for anyone? No, not this. This you have to. This is Resource Explorer. This is not needed. You have to say File, New.
I've created one.
Where? You can see Edit, View, Project Explorer.
I've created one and it comes like this, include MS430 .s, I think.
That is okay. So what they have done is they have added first statement of watchdog anyway. Right. Yeah, you write it down.
Yeah, yeah.
Okay.
Instead of lab1.c, you can go for the detail in the main.c.
You can write it.
Yeah.
That's what I said. People will not, everyone is not comfortable writing in C, right?
Yeah.
Few people are interested in understanding the architecture, and then okay, I mean coding part,
Yeah.
it's not everyone likes to do it, right? So I have kept those lab files differently, and then whoever interested, they can always write the codes.
Does it usually get this much time to open?
How long?
It's been almost a minute and a half. It's still
No,
processing.
I don't think. I don't think. Just wait for a minute more and then.
Probably I can shut it down.
I don't think it should take that long. Right? So, I mentioned we have to refer to this particular block. What should be my statement to make that as an output? Be loud, no problem. Pin 1. So what I have to write? You can look at it. Perfect. P1 dir bit 0 has to be 1, right? Write the statement. So my first statement is going to be P1 dir bit 0 will be high. So what this makes it as an output. So P1.0 as an output, right? To drive the LED high, right, that is not there. This is configuration part is done. So schematics we can refer, yes. Port schematic, circuit schematic, yes. A very valid point, I would have missed it. So just have a look at circuit schematic. Right? So we have to make it 1 since we are driving it high, then only it is going to turn it on. So what we have to make 1? How do I find out the resistor? Which resistor to be made 1? So P1 out is available in the data sheet. I go to ports, digital IOs. Everyone can't see like this? I am not able to see this. Huh? No, I have done it. Okay. So there is a P1 out which we have to write it as 1 to make it high, to drive that LED high, right? So write that as well. Just a second. Digital. Okay, perfect. IO resistors. So for port 1, to make it as output, you have to write as P1 out